So yeah, now you see I had to make a short break because of the side strain ANG. Yeah, now let's jump into the last chapter of this week and of the whole semester, which is semantic-based trajectories or trajectory mining, semantic-based trajectory mining. So yeah, obviously the difference, what we said before, to geometry-based trajectory mining is that we are now more interested in the semantics around the trip, so to say, around the trajectory. Yeah? So we don't care too much about location anymore, but try to give these locations specific meanings, semantics, and then use these semantics, these meanings, in order to mine some patterns. Yeah? And it's as I told you before in the previous podcast, it's mostly about those things that have a clear semantic or a clear meaning is when the objects, when the trajectories stop at a particular point. Yeah, so it's basically about stops and moves. So partitioning the trajectories in phases where the object is moving around, probably not so interesting, and parts of the trajectory where the objects seem to stop at some point, which could be some kind of region of interest or some point with specific semantics, a specific meaning. Yeah, so that's the basic idea. So let's jump in. Here it is. So first of all, one of the pioneering works here for semantic-based methods is this kind of conceptual view on trajectories as a spatial temporal object that has some more features that are dependent on the application. So we have probably some generic features independent of the application, and that is mainly maybe the time and the space dimensions. And then we have additional features, which we call semantic features now, that are dependent on the application. Yeah? Sometimes we also talk about, or name that, or talk about enriched geospatial data. So we enrich the spatial temporal data by additional features, semantic features, which come from the specific application. Yeah, so the trajectory is now a travel in an abstract space, in this semantic feature space, not necessarily anymore in a geospace, but also now somehow a travel or a trajectory in this abstract semantic space. For example, if we take a look at this one here, we have a 2D career space where we have the position, for example, lecturer or professor or whatever, and we have the institution. So this is a kind of location thing. This is a kind of geospatial thing. So the institution may be also associated with, of course, with some coordinates. So we have spatial temporal data again. But here, this dimension here is now also some kind of semantic feature, which is coming from there, or which is dependent on the application. And one object, one person in that case, can be represented as a kind of trajectory in this abstract space, spanned by position and institution. Yeah, and of course over time the position and also maybe the institution changes. So we see here that this person started as an assistant in Paris, became a lecturer in Paris. So all at the same institution, but changed their position, and then changed not only the position but also the institution. Yeah, so the person became obviously professor at Dijon, and then later on changed not the position, because the position stayed or remained professor, but changed to EPFL in Geneva. So that is a kind of example of an abstract feature space where we look at some objects in this abstract feature space over time. Yeah? And typically this abstract feature space also has a spatial aspect or a spatial feature, at least one. Yeah? Sometimes also just the coordinates, of course, as we had before. So semantic trajectories is what we want to find, of course. So this is a kind of semantic trajectory. So the idea is that we have, of course, trajectories like spatial temporal time series, so spatial time series, yeah, and we have geographic data, and now we enrich our original trajectories with these semantics on geographic data, like I don't know, here is the Eiffel Tower and somewhere else is somewhere else, yeah, and maybe here are some stops of hotels probably, and maybe somewhere else are the stops of the metro and stuff like that, yeah. So Eiffel Tower, so scenic positions, tourist spots, hotels, restaurants, metro stops and stuff like that. That would be geographic data, semantic data that can enrich the sheer raw trajectory data. Yeah? And then we have a combination of enriched trajectory data, and we can say, okay, these trajectories go not only from coordinate x epsilon to z whatever, yeah, but we can also say, okay, this trajectory is moving from the Eiffel Tower to the hotel, blah blah blah. Yeah? So, and that is what we mean, what we speak of if we speak of semantic trajectories. Yeah. So as I said before, the key challenge is the differentiation between stops and moves. Yeah, so we want to partition the trajectories, the semantic trajectories, into periods where the object stops for a while at some specific region of interest, and the other partitions are in between the stops, where the objects obviously move from one stop to the next stop. Yeah, so stops are typically then the important parts of the trajectories, because they somehow feature these semantic properties. We typically think that stops are those parts where the moving object has stayed for a minimum amount of time. So we typically define stops by means of some minimum time threshold. Stops are, of course, application dependent. Yeah? For example, for tourism application, we are more interested in hotels, touristic places, airports. For a traffic management application, we are not too much interested in hotels and touristic places, maybe also in airports, but more about traffic lights, roundabouts, maybe big events, because it's traffic management application. So is there a flash mob? No, flash mob is maybe a bad application, but anyway, you know what I mean. Yeah. So these stops, defining these stops is, or the importance of these stops is a little bit application dependent. So it depends not only on this minimum number of time threshold, but also on the application. Yeah, we'll keep that in mind. And as I said before, the moves are then those parts of the trajectory where we have no stop. Yeah. So once again, let me emphasize this here. Stops are dependent on two things: the minimum number of time where the object stayed at some specific point, and also on the application. Yeah, so it may be that a trajectory stays at a hotel, so the stop is a hotel, but we have an application where hotels are not interesting. So for this application, this would not be a stop. Yeah, so let's keep that in mind. And on the next slides, in the next podcast, we will talk about different methods how to actually determine stops and moves in semantic trajectories. Yeah? So stay tuned.